So my name is Brian Carter. I'm with a company called Optum. We've just recently opened up in Dublin. We're part of the United Healthcare Group, and so we do a lot of analytics in fraud in the health insurance market for the States. That said, none of the talk is about this, so it's all about NLP or some of the libraries in NLP. And I suppose one of the worst things about doing a talk at the end of a conference is a lot of people have stolen your work beforehand, but then you've got the advantage that you can critique some of the people's presentations that they've shown. So everything's up on my GitHub account, and I'll tweet the link to the talk after this. So basically, it's kind of a light talk. There's nothing too technical or too mathematical in it. So what I wanted to look at here is a part of NLP, part of speech tagging, and the different libraries that are available in Python for doing that. And just really to have a comparison, see what's the functionality, what's the speed of them, that sort of thing. So just the outline is just to introduce part of speech tagging, my motivation for exploring the different libraries, some experiences with NLTK, and then just have a quick look at what are some of the available NLP libraries, just quickly how they install, speed comparisons, and then just a summary at the end. So just to introduce part of speech tagging. So NLP is a huge discipline, and part of speech is only one little part of it. And so what are some of the tasks that you might want to do for part of speech tagging? So there is some of that functionality. I know there's been a workshop on NLP, and there's been a few talks in it. And so some of the functionality is already baked into scikit-learn if you're using it. So creating a matrix representation of your words, and then simple as counting your words with TF-IDF. And then what part of speech is actually deconstructing or parsing a sentence into what are the different parts of speech, whether it's a noun, verb, or an object that make up the actual the sentence. And then you might take that information and use it in a classification setting. So you want to do entity recognition or sentiment analysis, which is using part of speech, or the pre-processing for data for scikit-learn. So you can imagine, if you take your unstructured data and put it into a matrix representation in scikit-learn, you're going to get all the words. And there's a lot of techniques for taking out stop words and all that kind of stuff. But what if you just want to have a look at all the nouns? Or what if you want to have a look at all the noun phrases and use that as your features when you're training an algorithm? And then another part of, for why you might want to do part of speech, is the idea of production. So chatbots or speech to text. So there's a lot of development from the big companies around chatbots, and so Microsoft had one earlier in the year where they had a Twitter chatbot that was supposed to be a teenage girl, and then people gamed the whole system and turned her into this racist, awful demigod. Sort of thing. So actually, I think it's kind of an interesting area because there's a lot of companies are now trying to develop chatbots as part of their customer services. So there will be a lot of opportunity to game those systems, I imagine. Part of speech attempts to assign each word in the sentence a tag. And at a high level, those tags can be nouns or verbs or adjectives. And within that, then, there are many categories and subcategories. And it's this grammatical structure that you try and extract from the unstructured text that you can then feed into another application to help you reason about it. And I quite like this graphic in terms of displaying the sentence, "They ate pizza with anchovies." And the dependency parse is displayed there. And the red one indicates where the part of speech tagger has got it wrong. And so the pictures down below is they're eating pizza. On the left, the sentence is correct, and on the right, they're actually eating it with the anchovies, the fish sort of thing. And there's some of the things that can go wrong with it. So that's just sort of when we was talking about verbs and adjectives and nouns. That's the Penn tree bank parsing. part of it, not the full one, of all the different tags that you can have associated with a part of speech tag. And I'm not doing anything in terms of trying to build the models that create these tags. I'm just using the libraries that have already been built. And one of the things to be aware of with all the libraries is that they have been trained in certain contexts. So one of the main, so in the Penn Tree Bank, you've got a lot of the main corpus that everything is trained on is the Wall Street Journal. So when you then apply that to your text, maybe that doesn't fit. Maybe there's a huge bias in there because, like, I mean, it's been used on the Wall Street Journal. And so why do part of speech tagging? And I suppose that phrase, to let another application to reason about it, I think sums it up best for me. So it's that ability to be more precise about the information that you want to take out of structured text, depending on what the context of the problem that you're doing. And so you can extend your part of speech when you're creating your bag of words representation. So you can extract out noun phrases. So in the example here, the election year politics becomes a noun phrase, or annoying for many people becomes the noun phrase. Or you can extract entities, peoples and places out of it. And I was doing a project a couple of years ago doing topic modelling. And I came across this guy who has this post up called Secret Recipe for Topic Modelling Themes. And topic modelling is used quite a lot now in, well, not quite a lot, but a lot of humanities departments are using topic model to explore English language text, to see what are the patterns of topics or themes that are going through through different texts. So this guy, in one of his experiences, is like, that it doesn't capture everything, but it certainly captures the attitudes towards, or it can capture the attitudes towards the teams. And so he talks a lot about what is the stuff that you want to leave in. And so having the tags, the nouns and the verbs allows you to do that. And then, I was quite interested, Andreas gave a talk earlier on about probabilistic modelling. And there was one of the libraries was people probable. So I was just kind of sitting in the back and I said, okay, I'll try that and see how it works. And so this is kind of why the part of the justification, I would say, of sort of thinking about part of speech tagging when you're building models. So I just threw this up. And so this is the probable people package, and it's their example of George Bluth Gobb, and then you pass that in, you get what's the given name, the surname, and the nickname. And then I kind of like said, okay, well, what if that was in a sentence? So what a silly name George Bluth Gobb II has. And when you just throw that straight away into the probable people parser, it all comes back as being tagged as corporation names. But then, okay, what if you just try and parse the sentence first before? This is a MacBook. And so here I'm doing the part of speech tags. So I don't know, can you see that, or is it? It's all right. So it's all the words with their actual tags. And then by extracting out just the proper nouns out of the actual sentence and then passing it into the probable people parser, then we get a better result. So it extends that functionality to where you might have names within unstructured text. And so I just put that up, my motivation in terms of I'm a general data scientist, so I'm not an NLP expert. And so oftentimes I'm coming up with problems that have a significant amount of unstructured text. And so I've worked on a couple of different projects. So I worked on a project with a company where they had done a survey of their employees, and they had taken, it was a free text survey. And they really kind of went ahead and did the survey without thinking about how we're going to analyse all this data. And they had like thousands and thousands of responses. So as part of the solution for that, I used topic modelling. And so in that case, I used NLTK. and sort of came across some limitations with that. In another project I did, I was writing a chapter for a book, and I was analysing unstructured text from people who had reviewed ecstasy pills online. And so in that example, I started looking at different libraries that had become available for doing that. And then one of the speakers yesterday was talking about the Home Depot Kaggle competition. And so that was kind of in the summer of 26, or just this year. And there's another library called Spacey.io that's just come out, and it's about 2 years old now. And so I started using Spacey.io, and I saw there's significant improvements on the basic NLTK library when you compare some of these other libraries. So just to give an example of, say, some of the stuff that you might do. So this is for the project around analysing the ecstasy pill reviews. And so at the end, I wanted to stick in a word cloud, because you can't do NLP or text mining without putting in the obligatory word cloud. And when I was doing it, I was kind of, okay, how do I want to convey the different themes that are available, or that are in the different groups. And so I used the parser speech tagging. So you can see here in the second line. So what I'm doing is I'm building a word cloud, but I'm only taking adjectives and nouns to convey concepts just in the word cloud. And so that's kind of like means sort of the visualization that comes up at the end. And again, one of the previous speakers had talked about the Kaggle Home Depot competition. I suppose this is where I kind of really started looking more in depth at what were the available libraries. And so I won't go through, I don't know if people were here yesterday for this, but the Kaggle Home Depot competition was basically, they have a business problem where when they're updating their search algorithm, they are using human raters to evaluate if there's been an improvement in their search algorithm. And so what they wanted to do is, could they automate that process where they don't have human raters? So they provided a data set where they had supplied the search query and a product image and a product title that it was returned. So the user puts in a search query and they get a product title and a product image back. And they also get the product description. But in this case, the human evaluators were asked to look at what was returned based on the product description and then evaluate how good the returned result was, and with a focus on brand, material and functionality. So this is kind of what the data looks like in terms of, so you have the product title, you have the search term, so you have a Glacier Bay 2-piece dual flush, and then the search term is handicap toilet. And then the relevance then is an average of 3 human raters from 1 to 3. And again, this is kind of some of the, quickly doing the string lengths and tokenizing the product descriptions and getting the word length. And what I wanted to show here is there's about 100,000 or 120,000 rows of data in that. But when you total up the number of words across all the product descriptions, you're up to 17 million words. And in terms of speed, it was I started working with the Stanford parser, and I couldn't get the Stanford parser to work fast enough to be able to process this text or in a reasonable time. So that kind of was one of the sort of bottlenecks that I came to in working on this competition. And so that's kind of like means sort of another motivation for looking at parser speech taggings. So there's a number of different NLP libraries available for use. And I suppose this is an important point to when you're evaluating what library maybe you might choose, is what's the intent of those libraries. So there's a huge number of libraries that are based, that are for research purposes, that are used in universities, and it's really around pushing the boundaries of how accurate the parser speech taggers are in different contexts. And within each of those libraries, then the functionality differs. So how you, first of all, pre-process your unstructured data in terms of segmenting your segments or segmenting your sentences, tokenizing your words, or doing entity recognition. And they also differ in their output. And I suppose NLTK, which is the most popular, is the oldest library around, is probably your go-to for gathering and classifying unstructured text. You often use NLT for pre-processing tokenization, then feed it into the vector representation for machine learning. And it's got everything in it. You know, it's got the tagger, lemmontizer, a dependency analyzer, the sentiment analysis, but it can be slow. And if you, within each of those functions, you have to do multiple parses on the data. And so it's not very well optimized, and involving NLT libraries sometimes means you have to accept a performance loss. And so there are newer alternatives. So here's some of the libraries that I looked at or played around with. And I suppose, so there's 5 libraries: NLT, Spacey, Pattern, TextBlob, and Stanford. And the interesting thing about it is that the NLTK library for the part-of-speech tagger has a perceptron tagger that's written by Matthew Hannenball. And that was introduced in 2015 into NLTK, and it's the default. So if you don't change the default, that's what you're going to get now at the moment. This is the same guy who's written this library, Spacey. And so he's a huge amount of experience in NLP. It's kind of his life's work. So it's kind of interesting that NLTK is using a library that he has written, and to see how that compares with his own library that he's created. And then there's some other libraries out there, Pattern and TextBlob. And they are using, so the Pattern library is using a Brill tagger, which is quite an old part-of-speech tagger. And its focus is on ease of use. So in terms of that, you, again, it's unlike NLTK, where you have to do multiple parses on the data. Pattern is more, you only have to do one parse, and you get all the different types of information back that you want. TextBlob is built on top of Pattern, and it extends it towards doing web scraping as well. So you've got your web scraping and your NLP part-of-speech tagging all built into one package. And then Stanford, which is I suppose it has a claim of better accuracy, and it's using a different parse again. It's using a different model, a conditional log linear part-of-speech of tagger. So some other libraries that I wanted to include in this talk are the Stanford Core NLP and the SyntaxNet or Parseface that Google released in September. But when you start working with them, in terms of what my goal is in terms of using NLP or part-of-speech tagging in a more industrial setting as opposed to a research setting, these two libraries don't have Python APIs built. They're quite slow, and they are focused more on the research end of stuff. And so, like, I mean, I've tried and worked with them sort of thing, but it's kind of like, I mean, you have to mess quite a lot to get them to work, to bring in your data. You end up in the command line quite a lot, and yeah, I'm just like, Python's easier. So they're fairly straightforward for the installation for all of them. So for NLTK, it's just a pip install, and then you have to download the data. For Spacey, it's the same straightforward pip install, and then you have to download their English model. Pattern, you just pip install, there's nothing extra to download. And TextBlob, the same thing, you have to download the corpora. The Stanford parser is slightly different in terms of you have to download the different taggers and place them in a folder, and then you have to set up, because it's run with Java, you have to set up your paths to the Java to get that to work in Python. So This is just a very quick how do you actually set up and run the parsers. So they're all fairly standard and straightforward in terms of to set them up, and then you can just pass the text in, and this is the output at the bottom that you get from the parsers for where you've got your word and then your associated tag, whether it's a noun or an adjective, etc. So really kind of my focus in terms of this was looking at what's the speed differences across the libraries. And I suppose I've committed a cardinal sin at a PyCon conference as I've done a plot in ggplot with OR, but however. So the first thing to note is, so I just sampled on the Kaggle data set a number of times, and then totaled up, counted up the number of words, and on the y-axis then is the time it takes to parse in seconds, and they're all points. I think you might be able to see the points there. So the first thing to note is that the Stanford parser is very slow. There are probably lots of tweaks that you can do to it, but out of the box, it's significantly slower than all the other 4 parsers, the NLTK, Spacey, Text, Blob, and Pattern. So the next slide is, I just dropped out the Stanford parser in this graph, and then you can see the differences in terms of, so as the total number of words goes up, the time taken increases, nothing unusual there. And then there's kind of like the green line is the Spacey library, which is lower than the other 3. And then the NLTK and the text blob seem to be quite similar. And then as you scale it up for the number of words that you're parsing, you can see that there's a difference between the 4 different libraries, with Spacey being consistently the best library. And then I suppose the interesting thing is that for the other 3 libraries, as you're throwing more words at it, you may encounter a string of text that has very long sentences in it, and so you get much larger variation in your time to complete your parsing. And that's to do with the way the parsers are working in terms of a bidirectional scan, so it's keeping words in memory and scanning back and forth to determine what's the best tag as it's going forward. So I suppose the main sort of conclusion sort of out of this is, if you're not aware of the Spacey library, for me it's kind of now for NLPs like the go-to library for me. I'll come back to it in a minute just to discuss it a bit more in terms of some of the benefits of using Spacey over the other libraries that are available. To come on to accuracy, to come back to the earlier point I was making about that the parsers themselves are trained on text that may not be related to the text that you're looking at, or is biased in some way. So like the Wall Street Journal. So accuracy in parser speech tagging is subjective in terms of how accurate do you need, or what do you need the accuracy for. And then in terms of looking across all the libraries, what's the agreement? So if you look at all the 4 or 5 libraries, do you get the same tags coming out for each of the words if you throw in the same text? So I just took up this example of the unicorn mask is because we're data scientists and we're all supposed to be unicorns, and we're supposed to be unicorns. And this is from one of these reviews from BuzzFeed, which is a great business model of aggregating funny content from the web. So it's just to throw this review into each of the parsers and then look at the tags that come out. And so there's 157 words or something, I think, in that piece of text. And I just pulled out the ones where there was an agreement across all the taggers. And so there's no consistent ones you say, okay, they always agree. So you can see it's sort of the first major difference is from the sentence. I think it's like, as a unicorn myself. And so the NLTK is given back an adjective, whereas all the other parsers are given back nouns, and then myself becomes the noun in the NLTK library. And so that's why I say accuracy is subjective. It depends really on what your use case is going to be, where you're going to pull this information back. You're never going to be in a real world application be able to evaluate this in terms of which is the best library in terms of for this, because sometimes some of them will be right, but it also depends because language is ambiguous anyway. Even for human beings, we get language wrong all the time, so it's not unbelievable that the computer would as well. So that's really sort of the kind of the gist of the talk. In terms of then like doing a summary across all the different libraries. I suppose if I look at NLTK as being the baseline in terms of speed, Spacey has about a 20% improvement in speed. Pattern and text blob a smaller amount, and then Stanford in the data that I looked at was 250 times slower in terms of doing the parsing. These are the reported accuracies that the libraries themselves say that they have. Again, this is kind of, I would take it with a pinch of salt. It's quite hard to pull out that information from their documentation in terms of what is the accuracy. And even like, I mean, if you read any of the information about syntax next at the bottom or parsing parseface, when they're claiming 94% accuracy, but then there's a lot of debate about how they actually came up with that 94% accuracy. Moving on to the functionality, which I think is an important part of this. So in NLTK, it depends really on what the APIs that you're using into other parsers. But in general, you have to pass the text through multiple times. So if you want to get your part of speech tag, or you want to get your sentiment, or you want to get your lemma, you have to redo your parse over and over and over again. Compared to Spacey, you just parse once and then all that information is returned back and you can just access whatever part of the information that you want. The pattern and text blob, I suppose, are more aligned to the Spacey model of just parsing once, but they've a more limited amount of tags being returned. And the Stanford parser is similar to the NLTK. In terms of then languages, I only work in English. It could, for other people, it's probably important in terms of what available languages there are. So NLTK has a number of different languages, but again, you'd have to set them up individually, depending on what are the available parsers. Spacey has English and German at the moment. I think Spanish they have earmarked for some time next year. And pattern and text blob have English, German, French, Spanish, Dutch, and Italian. One thing to note about, I suppose, pattern and text blob, when you look at their Git commits, the last time they updated their libraries was January 15 and June 14. So it's kind of an indication that those libraries aren't going to be developed any further. So in terms of if you're trying to choose between a library, it's probably something to keep in mind. One of the other speakers spoke about using a library then that was no longer developed because it was bought. That's another consideration. NLTK is open source. Spacey is being developed primarily by two guys in Spacey. So it depends, you know, like will they be bought over or something like that. And then the other, if I can scroll here, some of the other stuff I didn't focus on was there's also APIs for doing part of speech tagging. So Microsoft have an API and Google have an API. Again, it depends on what your use case is in terms of the cost model. Microsoft has, I think, is free for a certain amount of parsers. And then Google is, I think Google is currently free, but I haven't used them as of yet in terms of determining how good they are. So that's my talk. So thank you very much.
Hi, thanks for the nice presentation. it's not more than a question, it's kind of a doubt. Like when you say parse, you means like a single reading or like a single pass? Because parse means like normally in NLP is like parsing of a sentence to create parse trees. So you mean like creating of parse trees, or like when you say like a single parse is like single reading of sentences?
It depends again which library you're using. So the dependency, if you're using Space, you get the dependency tree straight out as part of the parse that you're doing. And also it will segment up your sentences, so you can pass in the text as is.
Yeah, but that's why actually it creates a little bit doubt, because like you're comparing the performance of part of speech, but then you can run like a standalone part of speech taggers, even like in Stanford and even in NLTK. You need not run the whole pass trees.
I don't know. I'll have to
Yeah.
go back
Yeah.
and see if
Yeah.
maybe I've like introduced an error there. Yeah.
Yeah, cool. Thanks.
Okay.
Yeah, I just wondering there, has anyone looked at majority voting and between multiple parsers to see if that performs better than any of the... Has anyone tried to combine these different parsers to see if using majority voting is more accurate than using any of them individually?
I don't know. I'm not aware. There's, I suppose, the research is in different methods of parsing, but again, it's kind of like it depends on the context. How do you measure the accuracy on this? Because do you have a labeled data set available to do it? But I suppose the complexity then of combining all the different parsers. But yeah, I'm not aware.